All right, this video is meant for those students who are virtual or who just want a little more review with the lessons we did on rotations and reflections. And that's what we're going to be learning today. These are additional types of transformations. We have already seen translation, and now we are going to be doing rotation and reflection. And eventually we will start putting these things together, but for today we will consider them by themselves. Okay, just some vocabulary. A rotation is exactly what it sounds like when we take a figure and we turn it around some point. So we take an object, like a square or something, and we have some anchor point, and we will say that we're going to rotate around a point, usually the origin, but it could be some other point. And so when we do that, what we say is, let's say we're going to rotate 90 degrees. You imagine taking the points of your object and rotating, let's just say we go counterclockwise 90 degrees by the same amount. Right, so if you imagine this point is going to end up here, and then it's a little bit hard to show this without a graph, but this point will now end up at a 90-degree angle. And so what will happen is this shape will eventually all rotate and look like this. So each point forms a 90-degree angle with that point of rotation. Okay, this will be easier to show on a graph. Perpendicular lines, again, just intersect at 90-degree angles, and we're going to be talking about perpendicular lines and their slopes a lot when we do this example today. Okay, this would be an example of rotating an object by 140 degrees. We have the center of rotation, the point that we are rotating about, and then each of the points forms that 140-degree angle from the center of rotation. So if I drew another line, say going from one of the other points, let's just use red for a moment. Okay, going from this dot as straight as I can. Okay, and then, where would that correspond to? So on the other figure, we can see it's going to correspond to this point right here. If I draw a line back, okay, we can see it's going to make that 140-degree rotation. And the direction matters, right? We're saying it's counterclockwise in this case. Clockwise would be going the other way. And so one thing that's important to realize is that when we describe a rotation, we could do it in two ways. There are 360 degrees in any rotation, so if we rotate something 80 degrees clockwise, that is the same as doing the other direction counterclockwise. Okay, so if we go 80 this way, it is the same as going 280 in the other direction. You would end up with the same result. And so simply, for what is a rotation of 160 counterclockwise going to be the same as, you would simply say 360 minus 160 is 200 degrees clockwise. And it is okay if you abbreviate clockwise CW and counterclockwise CCW. That is fine. Okay, so any rotation can be described in two ways. A lot of times we are going to rotate by 90, 180, or 270 simply because those are nice coordinates to rotate by, or angles to rotate by, and the rules for where the coordinates are going to end up are ones that can be memorized more easily. Once we start rotating something by 50 or 60 degrees, then we need to involve trigonometry and things like that, which is going to be a lot more difficult. There are rules, and I will teach those rules to you, but I'm going to show you that you don't really need to memorize these rules so much as just kind of think about what's going to happen. If you think about, looking at this graph, let's get red here, right? If you rotate something 180 degrees, first of all, that's a straight line. And we know that, right? 180 degrees, it opens all the way up and makes a straight line. And so if you think about it, you're going to rotate, you're going to rotate around the origin by that amount. But let's just think about drawing this line, right? The slope of this line is going to be the same on both sides. So let's just say, I'm just making up some numbers here, but let's just say, this is 2 and this is 3. Well, that means we're going to go over and back by the same amount. So if this coordinate, therefore, right, if this was 2 and this was 3, that would mean this coordinate, we're going 2, but we're going this way, so this would be a negative 2. And again, we're going this way, but we're going down, so that's going to be negative 3. And so we can see what happens is we started with 2, 3. We ended up with negative 2, negative 3. And that's what this rule is trying to say. Okay, when we rotate a point 180 degrees about the origin, which should really say, then what will happen is you simply change the sign of the coordinates. And we'll do some examples with graph paper to show why this works. Okay, and this works no matter where you're rotating from. So you might see a question like this. Okay, we give you a triangle with vertices. So let's start by graphing those vertices. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Okay, there's point A. Should always label your points. And then 6, 1. That's point B. And then 3, 1. Okay, and that's point C. And they're telling us that's a triangle. So let's go ahead and connect those. Okay, I'll use a different color here just to show you what's going to happen, but you don't have to do this every single time, drawing these lines that I'm about to do, but it's just showing you what's happening here. So let's just start with point C because it's closest to the origin. We want to rotate it 180 degrees about the origin. So again, we're just going to draw a line straight to the origin and then do the same amount on the other side, right? Because 180 has got to be a straight line. And that's going to be your new coordinate. Okay, that is C prime, we say. Well, we went, again, what did we do? We went down 1 over 3. So let's do the same thing, over 3, down 1. And we can see the coordinates of C were 3, 1. And the new coordinates, right, the coordinates of C prime are going to be negative 3, negative 1. So what happened? Very simply, the coordinates switch sign. So I don't have to draw these lines. Now I can just think about, okay, well, if B is 6, 1, that means B prime is going to be negative 6, negative 1. Okay, you can simply apply that rule and save yourself some time. So negative 6, negative 1, that's going to be B prime, and then C prime, A prime, I'll just write it over here for room. A prime is negative 7, negative 4. So negative 7, negative 4 is down here. Okay, draw your picture. And then you should always do a visual check to make sure, does the shape look the same? Yeah, it does. It just looks like it was flipped over. It looks like it was rotated, which is what we're looking for. But if you really, really, really want to be super careful, you could, let's use like purple, draw those lines. So let's do A, draw a line straight back and then straight through the origin. And sure enough, you end up at A. Okay, if of course I'm doing this freehand, but if you took a ruler, it should be a nice straight line from one to the other directly through the origin, if you've done everything correctly. And that's the idea. Okay, rotating 90 degrees is going to be very similar. So let's just say we start with a point, right here. Let's not do 3, 3. Let's do like 4, 2. And I'll just call that A. Okay, let's say we're going to rotate 90 degrees, and let's say we're doing it clockwise. So we want to go this way. Okay, so again, what we're going to do is we're going to imagine I'm drawing a point directly to the origin, and then I want to form a 90-degree angle with the origin. Well, okay, when we do that, right, what's happening? We're getting perpendicular lines. Okay, so perpendicular will come into this. Well, what do we remember about perpendicular? Right, we're going to get opposite reciprocal slopes. Right, so we went over perpendicular lines have opposite reciprocal slopes. So, think about the slope of the line on top. Well, to get to the point 4, 2, that must mean we went up 2 over 4. right, to get to point A. Well, that means to get to point A prime, we're going to want to do the opposite thing. We're going to want to go down 4 over 2. And I realize that reduces to 1/2 and 2, but we need to go by the same amount, right? We're not just taking the slope of this line, we're using it to help us find the location of the new line. So now let's go back to purple here. Okay, so what I'm trying to say is, right, we went up 2 here, over 4 here. So now we want to do the opposite reciprocal thing. Let's go down 4, 1, 2, 3, 4, over 2. Let's put a dot there. And look what happens when you connect those. Okay, if you had a ruler and you made this nice and straight, you've made that 90-degree angle there. And so that is the location of A prime. Now, what are the new coordinates? Well, they are 2, -4. So what happened, right? We started with 4, 2. We can get rid of these lines now, right? These were just to help us figure out where it ended up. We don't need those. Those are not part of the diagram now. Okay, we rotated our point. It ended up here. What happened to the coordinates? Well, we started with 4, 2, and we ended up with 2, -4. So these switched places, right? The 2 and the 4 switched, but we ended up in this quadrant. So where in this quadrant both coordinates are positive, right? In this coordinate, we know the y coordinate is going to be negative while the x remains positive. Okay, let's try this now going the other way, right? Instead of going clockwise, let's go counterclockwise. And of course, if you want to pause the video at any point and try this yourself, you're certainly welcome to. Now we could think of this 2 ways. We could start at this original point and do the same thing, but we can also realize, right, if I started here and rotated 180, that would basically, 90 here, and then another 90 here, right, would take care of that. So how do we do 180? Well, we said, remember, go straight through the origin. So go by this same amount. And notice we're going to get that opposite reciprocal slope again, right? This was 2 over 4. This is -4 over 2. And so sure enough, right, if we end up back here, we can see we're going to get that 90-degree angle. Well, what are the new coordinates? Over here, let's see, they'd be -2, +4, and we'll just call this a double prime. Well, again, starting with your original coordinates, what happened? Again, they switched places. The 2 and the 4 changed, but now we need to be careful. We're in this quadrant. So all the x coordinates are negative while the y remains positive. Okay, so what I'm trying to do is show you that you can do this geometrically, okay, drawing lines and thinking about the slopes. Now you could also memorize a rule if that's going to be easier for you. Okay, there are these rules. When you rotate by 90, and again, this is always around the origin. Everything we're doing today is around the origin. The signs are going to switch, and you're going to change based on the quadrant you're in. Now, you can memorize the, negative x or negative yx. Like, you can memorize these. I found students have a hard time learning these. So certainly, if you want to write them down somewhere and have them, that's great. And if it works for you, fantastic. But I'm going to recommend something much easier, which will work for 90 and 270. And remember, 270 is the same as rotating at 90 the other way, right? So if we go 90 this way, it is 270 this way. So we don't need to learn a separate rule for 270 because we can just think of it as being 90. Okay, rather than this, here's what I recommend. When you rotate something by 90 degrees or 270, you're basically always going to do the same thing. You just need to think about the quadrant you end up in, right? So, if you're starting in quadrant 1 and you're going to rotate 90 degrees clockwise, you're going to end up in quadrant 4, for instance. So you want to imagine where you're going to be. You can draw it if you need to. The coordinates will always switch, right, no matter what. So, to give you an example, let's just say we're starting with, 4, -3. Okay, well, where is that going to be? That's going to be in quadrant 4, so somewhere down here, 4, -3. And let's just say we're going to rotate this clockwise by 90 degrees. Okay, well, so going around the clock, right? Every 90 degrees is just going to move me to the next quadrant. So 90 would get me here, 180 would get me here, 270 would get me here, 360 will get me back where I started. So I'm going to end up in this quadrant. So think about it. Okay, over here, both coordinates are negative. And if it helps you, right up here, the x coordinate's negative and the y coordinate's positive. Here they're both positive. And here, right, the x is positive while the y is negative. So if I rotate this way, I'm going to end up over here. So what do I do? Okay, if this is, let's just call it b, then b prime, I'm going to start by switching my coordinates. But if I did that, that wouldn't be right. Okay, negative 3, 4 couldn't be in this quadrant because they both need to be negative. So I'm just going to change what I need to fix. And that's going to work. So very simply, figure out where you're going to be, switch the numbers, and then just change what you need to be negative or positive based on the quadrant you're in, and that will always work. Okay, we'll do a few more examples to make this solid for you. Again, you can memorize these rules if you want. I have found students have a lot more success with this. Your choice, however. Okay, so let me show you an example. And you may want to try this yourself. All right, so rather than rotate individual points, usually we'll be rotating some object. And so in this case, we are rotating this line segment. Let's use red. Okay, ST, and then these are supposed to be the endpoints. The easiest way to rotate any object is to rotate its individual points. And so we are rotating 90 degrees counterclockwise. Well, counterclockwise would be going this way. And again, each 90 takes you one quadrant, so we're going to end up in here. Okay, so we know that means both of our coordinates are going to need to be positive at the end. Well, so let's see, 6, negative 1. That's going to become 1, 6. Okay, we switch the numbers, but if I just switched them, that wouldn't make sense, right? Negative 1, 6 would be over here. That's no good. So, okay, so then we just say, well, what do I need? I need both to be positive, so let me just get rid of that negative sign, and that's going to work out. 1, 6. Let's put a dot. And check. If you really want to check, take your ruler, draw some quick lines, right? Does that make a 90-degree angle? Close enough for me. Right, I feel pretty good about that. But you don't have to do that. Yeah, it's just a way to check. Call it S prime. Please label it. Okay, T, same thing. 2, negative 8. So we're going to switch them. But if you made it negative 8, 2, that's not going to make sense. So let's get rid of that negative sign. 8, 2. It's going to make more sense. 8, 2. Okay, connect. And call that T prime. Does it look like the same line? Yeah, it's the same length. Okay, it's just been rotated. And again, if you really want to double check, quickly draw that line back, quickly draw that line back to the origin. Does it make a right angle? It looks like it does to me. And so we're feeling pretty confident. One more example. Again, you might want to try this one, so pause the video. You don't need graph paper. It's okay if you just draw a rough sketch. All right, 270 degrees counterclockwise. So again, counter would be going this way. And so we are going to end up in this quadrant up here. Okay, you could also call this a 90-degree rotation clockwise. So if I'm in this quadrant, I know I need my x coordinate to be negative and my y coordinate to be positive. So you can draw lines, you can do the geometric thing if you need to, but very simply we can go start by switching our coordinates. So 3, 1, 3, 5, 1, 1. Okay, when we switch, so just start with the numbers, right? Switch the 1 and the 3, the 5 and the 3, and the 1 and the 1. Of course, 1 and 1 just stay the same. But now just think, what needs to be negative? Okay, I'm in this quadrant, so my x needs to be negative, and my y needs to be positive. Okay, you don't have to do a lot of drawing and a lot of thinking if you just apply this process. Okay, what you should do though is graph them just to be sure. Okay, even if you're not being asked to, it's always a good idea to draw a picture. So P prime goes here, Q prime goes at -3, 5, and R prime -1, 1. And first of all, again, does it look like the same shape? It does, right? It shouldn't be stretched out. None of your lines should get bigger or smaller. You're simply rotating it across the page. All right, and again, you could check the line going from R prime to R, and that does make 90 this way, so we know that's going to make 270 this way. Okay, if you did the same thing for P and Q, you would find the same result. That is rotation. So again, just recapping that one more time, 180 goes straight across. Simply change the sign of the coordinates. So 3, 1 becomes -3, -1. And rotating by 90 or 270, you can use these rules if you wish. Probably just easier to use this process. Switch the points, or switch the coordinates rather, and then just decide what needs to be negative and positive based on where you are. Right, the other part of this lesson is reflections. When we reflect something, we think of it as like a mirror image. Okay, it is a transformation that takes a shape and reflects it or flips it over a line called the line of reflection to generate a new image. And you can reflect over any straight line. Most often in this class, we are going to reflect over the axes or y equals x or y equals -x are the things that we would see. And we'll go through some examples of how to do these. Okay. When you are being asked to reflect across a line, you can just draw a picture and just think about what's going to happen. And a lot of times this is just as easy. Imagine again, this is like a mirror, and what's going to happen? Okay, the distance of an object to the mirror is going to be the same as the distance from the mirror to its reflection. So if A is 3 units away directly from the mirror, that means A prime is going to end up 3 units this way. Okay, and that's what this diagram is showing here. Okay, C is 1 unit away. So C prime is going to be 1 unit away. And likewise, B is 5 units away. And so B prime, same thing. Okay, so you can simply look and decide like, okay, I just need to go by the same amount in the opposite direction from the line of reflection. And that will work just fine. It's a little bit harder with diagonal lines. It's easier with straight lines, horizontal and vertical, that is. Okay, but if I was asking you to reflect across the line y equals -x, just remember that has a y-intercept of 0 and a slope of -1. Okay, so like this. It's hard to freehand this, but I'll do the best I can. There we go. All right, this is the final answer, but how would we get there? Okay, when you do this, you need to think about going from the point to the line of reflection at a right angle, right? We need the shortest distance. So if you think, this would get you there, but the shortest possible distance between two objects always makes a right angle. And so, right, think about what happens. You went 1 unit this way, so you'd want to go 1 unit this way. Okay, that same slope. And that's going to be C prime. Okay, and that's how we're getting that part of the image. Same thing, B, now it's on the other side of the line, so that's okay, we just flip the other way. This is going, if we went like this, we would go by the same amount and end up over here. And then A prime is on the line of reflection, so it simply doesn't go anywhere, right? It's really a distance of 0 from the line of reflection, so it just stays put. And so in that case, what you can do is you can put like slash and say that A is really just also A prime. That's fine. Okay, and I realize the picture is drawn to the right, but this is showing you how we're getting there. You may want to try this one yourself. Same thing, we're taking a line segment and reflecting it across the line y equals negative x. And we're going to notice a pattern from this. Okay, so if you've tried this yourself, this one went half a unit, right? So it's going to go half a unit over here. And this one going straight kind of goes like 1.5 units. So we'll go 2.5 units rather. So we'll go 2.5 units this way. Okay, but now we'll look at our coordinates and we'll think about what happened, okay, trying to find a pattern so that we can use a rule instead of having to draw it every single time. Okay, so the original coordinates of S were -3, 4. The original coordinates of T were -3, 8. And then, where did they end up? Okay, S prime ended up at -4. Sorry about that, -4, 3. T prime ends up at -8, 3. Okay, so we look at this for a while and we try to come up with a pattern. First of all, it looks like these numbers flipped around. Okay, 3 went to where 8 was and vice versa. And also, it looks like the signs changed, right? So the 8 became negative and the 3 became positive. Okay, and so what's happening, right, if we take a general point, we'll write this on the next slide, right? X comma y is becoming, well, first we switch them, right? Y, X, but then also we're changing their signs, right? So whatever was in the y coordinates, like in this case, we started with 8, it's going to now end up in the x coordinate, but be the opposite of what it was before. Okay, and it turns out this is always going to happen when you reflect over the line y equals negative x. Okay, you can draw another diagram if you want to confirm that yourself. But if you trust me, those would be the rules that we'll learn here in a minute. Okay, here's another example. This one is asking you to reflect across the axis, right, the y-axis. So again, you may want to pause and try this one yourself just to see what happens. Let's get our red pen. D is going to end up over here, right? 3 over. 3 over. Again, it's a little easier to see with vertical lines. D prime. A is going to end up over here. C is going to end up over here. And B is going to end up over here. Okay, connect as best we can. Visually confirm. Does it look like the same shape? Yeah, just the mirror image, right? It's flipped over, but nothing is stretched out, nothing got bigger, none of the lines changed their slope, besides the fact that, instead of being positive, it's negative, but we're going up and over by the same amount. All right, so let's look at the coordinates again, see if we can come up with some kind of pattern. Okay, we'll write them all down. A, B, C, D. Okay, A originally was -4, 3. B originally was -4, -3. C was -1, -2. And D was -3, 4. Okay, well, what happens to those? A prime ends up at 4, 3. Okay, B prime ends up at 4, -3. C prime, 1, -2. And D prime, 3, 4. Okay, now, step back and ask yourself, like, what's the pattern here? The y-coordinate is not changing, right? 3, 3, -3, -3, -2, -2. Okay, the y-coordinate is staying the same. The only thing that's happening is the x-coordinate is changing sign, right? -4 becomes 4, -1 becomes 1. And, think about why that is. We're starting on this side of the axis, and we're flipping it over to this side of the axis, right? X is negative over here. Well, now it's just going to be the same x-coordinate, but made positive on the other side, right? The distances are all the same. We're the same distance from the y-axis. It's just a matter of the direction that we've gone. And so if we were going to make up a rule, we would say any point xy is simply going to become negative x comma y. We're simply going to change the sign of the x coordinate. So we come up with some rules. And you should probably write these down somewhere. We don't always want to draw the picture. Pictures are helpful, but sometimes we're dealing with shapes that are complicated, or, what are the coordinates, like 120 something, right? You don't want to get graph paper out for big numbers, so it's good to know what you can do in that case. Reflecting about the x-axis is going to be very much like the example we just did. Think about what's going to happen, right? If you reflect across the x-axis, your point is going to have the same x-coordinate, but now, if this was a distance of 2 this way, now it's going to be a distance of 2 that way. The y-coordinate is simply going to change, flip. If it used to be positive, now it will be negative and vice versa. Right? And we just saw if we're going about the y-axis, again, a picture is helpful. If you flip this way, you're going the same distance, okay, and the y-coordinate is going to stay the same, but the x-coordinate is simply going to change sign. Likewise, you can memorize some rules for y equals x and y equals negative x. We already saw this one on a previous slide, right? Going about y equals negative x, you flip the coordinates and switch the numbers. So you flip the numbers around and you change both of their signs. Okay, for y equals x, what happens is you end up just switching the coordinates. So in other words, 4, -3 will simply become -3, 4. You change the order of the numbers, but you don't change anything about their signs. And those are all the rules for today. I'll just go through a few more examples. Okay, so these would be questions you might see like on a quiz or a test. What are the new coordinates when the point B is rotated over the x-axis? So we simply just need to say B prime and give the coordinates. If you need graph paper, of course, go ahead and use it, but drawing a quick picture might help you. So B, let's see, 20, -35, that's going to be over here, right? Just a rough sketch. You don't need to draw all the tick marks and all that. Just a rough sketch is great. To the right and down. Well, if I go over the x-axis, that means I'm going to rotate it, reflect it rather straight up this way. Well, that means my x-coordinate's going to stay the same, and now my y-coordinate's going to change. Okay, it's just going to become positive 35. Instead of going down by 35, I go up by 35. Okay, if I reflect over the line y equals x, all I need to remember is the rule. xy becomes yx. I simply switch my points around. That's it. No work required. Nothing needs to be shown. You don't have to say anything. You can simply apply a rule. Now, there's no work, really. 2 more examples, and you may want to try these yourself. Okay, so reflecting over the y-axis. Again, you don't want to get out the graph paper for -200, 500. You just want to think about where it is. -200, -500, down here. Good enough. And what am I going to do? I'm going to flip it over the y-axis. So I'm going this way. Well, my y-coordinate would stay the same. The only thing that would change is my x-coordinate. And I'm done. That's fine. You don't even need to draw this picture. You really don't have to show anything if you're able to just think about it. But a lot of students find a quick diagram to be helpful. All right, and then likewise, we just need to know the rule for this. xy becomes -y, -x. We switch the points or the coordinates around and we change their signs. So 294, comma, -173. Switch them around and change the signs. And that is the lesson for today. Okay, so there's an assignment on Canvas called Unit 1, Lesson 3 and 4. I'll throw that in there. If you're at home, please finish this sometime before Wednesday, before class, and let me know if you have any questions at all. Feel free to shoot me an email. And have a great day.